What explains the haunting mathematical elegance that permeates our reality? The Fibonacci sequence spiraling through sunflower seeds, the golden ratio appearing in galaxy formations, and fractal patterns repeating endlessly from coastlines to cloud formations. These might be signatures of an intelligent design far more sophisticated than we've imagined. Consider the spiral arrangement of seeds in a sunflower head. Each seed is positioned at precisely 137.5 degrees from the previous one, the golden angle derived from the golden ratio. This arrangement is mathematically optimal for packing the maximum number of seeds in the available space. This same pattern appears in pine cones, pineapples, and the arrangement of leaves around a stem. The golden ratio itself, approximately 1.618, appears with remarkable consistency throughout our world. From the proportions of the human face to the spiral arms of galaxies, this mathematical constant creates structures that humans instinctively recognize as beautiful. The nautilus shell's logarithmic spiral grows according to this ratio, adding chambers that maintain perfect mathematical proportion, like a programmer's signature combining efficiency with aesthetic harmony. Fractal patterns represent another layer of mathematical beauty in our potentially simulated reality. A fractal is a pattern that repeats itself at different scales, what mathematicians call self-similarity. We see these patterns in tree branches, lung structures, river networks, and coastlines. Each smaller part resembles the whole, creating infinite complexity from simple mathematical rules. Imagine standing on a rugged shoreline, feeling awe at the endlessly varied patterns of water meeting land. That emotional response might be triggered by recognizing, unconsciously, the elegant code that creates such complexity from minimal input. Nature's compression algorithm generating infinite detail from finite instructions. What's particularly striking about these mathematical patterns is that they exist independently of human perception. The Fibonacci sequence and golden ratio operated in nature long before humans discovered them mathematically. Trees didn't learn to branch in fractal patterns because Benoit Mandelbrot developed fractal geometry in the 1970s. These mathematical structures seem woven into the fabric of reality itself, suggesting an underlying order, exactly what we might expect in a carefully designed simulation. The quantum world offers even more remarkable examples of mathematical beauty. Quantum mechanics can be expressed through equations of astonishing elegance, describing fundamental particles and forces with mathematical precision that physicists often describe as beautiful. The Schrödinger equation, which describes how quantum systems evolve over time, possesses a symmetry and simplicity that seems almost too perfect for a randomly occurring universe. Like a master artist whose brushstrokes reveal their distinctive style, these elegant equations suggest a creator who values mathematical harmony at the most fundamental level of reality. But here's the paradox at the heart of our simulated reality. Does knowing that a sunset might be programmed make it any less beautiful? When you stand at the ocean's edge watching the sky transform through impossible gradients of color while waves crash rhythmically against the shore, does the emotional impact change if you recognize it as an algorithmic process rather than natural phenomena? The conscious experience of beauty remains unchanged regardless of its source. Art and music illustrate this principle perfectly. When a piece of music moves you to tears, the emotional response is real regardless of whether the music comes from vinyl, digital bits, or a simulation within a simulation. The neural and emotional responses to beauty occur within our consciousness, making them real in the most meaningful sense. The same applies to our experience of natural beauty. The awe we feel standing beneath a star-filled sky comes from within our conscious experience, not from the objective reality of those stars. This perspective shifts our focus from the material origin of beauty to the consciousness that perceives it. Perhaps consciousness itself is the true miracle, regardless of whether it exists in base reality or a sophisticated simulation. The ability to experience wonder, to perceive patterns, to be moved by beauty. These capacities would be extraordinary achievements for any programmer to create. Artists have long recognized this truth. Throughout history, artistic movements have emphasized that perception matters more than physical reality. Impressionist painters captured the experience of perceiving a moment of beauty rather than objective reality. Modern abstract art often focuses entirely on evoking emotional responses through pattern, color, and form. These artistic approaches acknowledge implicitly what simulation theory suggests explicitly, that subjective experience holds more inherent value than objective reality. Scientists, too, find wonder in mathematical patterns regardless of their origin. Richard Feynman remarked on the beauty he found in equations, stating that scientific discovery revealed patterns of such elegance that they inspired awe similar to appreciating great art. Understanding how a rainbow forms through refraction adds another layer of appreciation to its beauty. When we recognize that the value of our experiences lies in consciousness rather than material origin, many philosophical problems dissolve. The question isn't whether reality is real in some absolute sense, but whether our experiences have meaning. And meaning arises from consciousness, not materiality. The love you feel for another person doesn't become less meaningful if you're both simulated beings. The wonder you experience witnessing a perfect snowflake doesn't diminish if its mathematical symmetry comes from programming rather than physical laws. This perspective offers a profound resolution to the existential crisis that might follow accepting our status as experimental subjects. By locating value in consciousness rather than material reality, we find that nothing essential has been lost. The beauty we experience remains beautiful, relationships remain meaningful, and moral choices remain significant. Perhaps even more so if they're being observed and evaluated by our simulators. Beyond the experiment, transcending the lab.